Hello everyone, welcome to the next session of ANSYS Workbench tutorials. In this session, we are analyzing a truss bridge for its static structural analysis. Let's start by double clicking on static structural. Next, I'll go to engineering data. I am not changing the material, I'll leave it to the default material of ANSYS, that is structural steel. Then we'll go to geometry and right click, new design modeler geometry. Units, I'll choose millimeter, XY, look at, sketching, I'll choose polyline. This is the first truss that I've drawn. Now I'll draw the rest of it. Let's give it some dimensions. Say each one is 85. Also, I'll determine the height. 35. I'll go to concept, lines from sketches. The sketch has to be selected. Apply, generate. Now I'll give it a cross section. I'll go to concept, cross section. Let's choose circular and give the radius as 3 mm. Here I'll change the line body cross section to circular. This is the 2D geometry that we have created. Now I'll go to model and double click on it. You can see here the geometry is of a line body. I'll go to mesh. I'll change the sizing to fine and update. You can see here this is the truss bridge created. Next I'll go to static structural. I want to apply fixed on these ends because these are the ends which are fixed on certain land. So I will go to point and choose these points. Right click, insert, fix support at the two vertices, and at the center point is where you apply the load. So I'll select this point and insert force. I'll choose component. The direction is Y, you can see from here. So let me give a load of minus 500 Newton. I want to see the static structure analysis. So I want to see the deformation, directional. I want to see the deformation along the y-axis. Also, I want to see the stress generated. So I'll go to beam tool results. You can see here there are two types of stresses. One is direct stress and the other is the combined stress. Direct stress is because of the load applied. So you can have a compressive type of load on the truss bridge. And when I say combined, it will be the compressive load plus the bending effect that is created. And that can be of two values. One will be minimum and maximum. So it is showing here in the beam tool results. Also, if you want to see the force reaction, you can go for it. So I want to see the force reaction on the fixed support. If you want, you can see the moment reaction also at the fixed support. Apart from this, if I go to beam results, since there is no actual force what I will get is some amount of shear force we can see. Also we can see the bending moment over this truss. I'll go to solution and solve. Let's see the results. This is the first directional deformation result that we have obtained. You can animate and see the result. Now this is just a single bridge element we have created. You can create a series of it and check the result. Next, let's talk about the direct stress. You can see here, since the load is applied at this zone, at the central part, so I can see the maximum stress on the rods which are connected at that end only. So you can see something like this when you animate. You can see this is the combined stress, minimum value, and one is the maximum value over this truss bridge. You can check the force reaction value from here. You can see the answer is correct because we have applied 500 Newton along the y-axis. So it was in the downward direction, and the force reaction here is 500 Newton in the y-axis. The x and the z value which you can see over here are actually quite less. So the summation is approximately equal to 500 Newton itself. You can just validate the results from here. Next, we'll go to the moment reaction. Along the x, y and z axis, you can see these moment reactions. Then we can see the total shear force on this body. At the zone over here, first node, here the value of shear force will be 0. You can check here at this zone. And at this zone, also the value will be minimum. The maximum value will be somewhere at this portion. You can see here the color is red. 5.4717 Newton is the value of the shear force. This is the bending moment that you can see. The effect will be obviously maximum here at this portion because that's where you have applied the load. So that's where you find your maximum bending moment. So this is how you analyze and interpret the results of a truss bridge for a simple static structural analysis. You can analyze this by changing the cross sections of the truss bridge. Say you can choose a hollow tube, you can choose a rectangular tube. I have taken a circular one. You can choose any other type. You can change the dimensions also and check for it. You can create a longer length of truss bridge, and at the central portions you can apply load and you can check for it. So with this I end the session. I hope you have understood how to analyze a truss bridge for its loading analysis and how to calculate its force reaction, moment reaction, shear force, bending moment over the truss bridge. You can also validate these results with the help of your numerical calculations. If you have any doubts, please write to me in the comment section. Don't forget to like, share and subscribe to the channel. Hit the bell icon for latest video updates. See you in the next session. Thank you.